Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Orchestration platforms, e.g. Kubernetes. Orchestration platforms, such as Kubernetes, have revolutionized the way organizations manage and deploy containerized applications. These platforms provide a robust framework for automating the deployment, scaling, and operations of application containers across clusters of hosts, offering a solution to the complexities associated with container management. Kubernetes, an open-source orchestration platform originally developed by Google, has become the industry standard due to its extensive features and active community support. The primary function of Kubernetes is to manage containerized applications across a distributed infrastructure, ensuring that the desired state of the application is maintained. This involves deploying applications, scaling them up or down based on demand, and handling failovers to ensure high availability. Kubernetes uses a declarative approach, where users define the desired state of the application, and the platform automatically adjusts the system to match this state. This model simplifies the management of complex applications, enabling developers to focus on writing code rather than managing infrastructure. One of the key components of Kubernetes is the control plane, which includes the API server, etcd, scheduler, and controller manager. The API server acts as the central hub for communication, handling requests from users and other components. The etcd is a consistent and highly available key-value store used to store all cluster data, ensuring data consistency and reliability. The scheduler assigns workloads to specific nodes based on resource availability and predefined policies, while the controller manager oversees the state of the cluster, ensuring that the desired state is maintained. Kubernetes also includes several abstractions that simplify container orchestration. Pods, the smallest and simplest Kubernetes object, represent a single instance of a running process in a cluster. Pods can contain one or multiple containers that share storage, network resources, and a specification for how to run the containers. Deployments are higher-level abstractions that manage the lifecycle of pods, enabling rolling updates, rollbacks, and scaling. Services provide a stable endpoint for accessing a set of pods, facilitating load balancing and service discovery. These abstractions allow developers to define complex applications using simple and reusable components. The scalability of Kubernetes is one of its most significant advantages. By leveraging horizontal pod autoscaling, Kubernetes can automatically adjust the number of pod replicas based on observed CPU utilization or other custom metrics. This ensures that applications can handle varying levels of demand without manual intervention. Vertical pod autoscaling, another feature, adjusts the resource limits and requests for containers based on usage patterns, optimizing resource utilization and reducing costs. Cluster autoscaling further enhances scalability by adding or removing nodes based on the overall resource requirements of the cluster. High availability is another critical feature of Kubernetes. The platform ensures that applications are resilient to failures by automatically rescheduling pods to healthy nodes in the event of a failure. This is achieved through health checks and self-healing mechanisms that continuously monitor the state of the cluster. If a pod fails, Kubernetes will automatically restart it, and if a node becomes unavailable, the platform will redistribute the pods to other nodes. This ensures that applications remain available and performant even in the face of infrastructure failures. Security is a paramount concern in any orchestration platform, and Kubernetes offers several features to secure containerized applications. Role-based access control allows administrators to define granular permissions for users and service accounts, ensuring that only authorized entities can perform specific actions. Network policies enable fine-grained control over the communication between pods, restricting access based on IP addresses and ports. Secrets management provides a secure way to store and manage sensitive information such as passwords and API keys, preventing unauthorized access. These security features help organizations protect their applications and data from potential threats. Kubernetes also integrates with various cloud providers and on-premises infrastructure, offering a flexible and portable solution for container orchestration. This allows organizations to deploy applications across different environments without significant changes to the underlying infrastructure. For example, Google Kubernetes Engine, Amazon Elastic Kubernetes Service, and Azure Kubernetes Service provide managed Kubernetes services that simplify cluster management and reduce operational overhead. These integrations enable organizations to leverage the benefits of Kubernetes while taking advantage of the unique features and capabilities of different cloud providers. The adoption of Kubernetes has been driven by the need for efficient and scalable container orchestration. According to a survey conducted by the Cloud Native Computing Foundation, 91% of respondents reported using Kubernetes in production environments. This widespread adoption highlights the platform's effectiveness in addressing the challenges associated with container management. Organizations across various industries, including finance, healthcare, and e-commerce, have successfully implemented Kubernetes to improve their application deployment processes and achieve greater agility. However, the complexity of Kubernetes can pose challenges for organizations, particularly those with limited experience in container orchestration. Setting up and managing a Kubernetes cluster requires a deep understanding of its components and architecture. Additionally, the platform's flexibility and extensive feature set can lead to an overwhelming number of configuration options. To address these challenges, many organizations leverage managed Kubernetes services, which abstract away much of the operational complexity and provide a more user-friendly experience. The future of Kubernetes looks promising, with ongoing developments and contributions from the open-source community. Emerging technologies such as service meshes and serverless computing are being integrated with Kubernetes to further enhance its capabilities. Service meshes, like Istio, provide advanced traffic management, security, and observability features for microservices running on Kubernetes. Serverless frameworks, such as Native, enable developers to deploy and manage serverless functions on Kubernetes, combining the benefits of serverless computing with the flexibility and control of Kubernetes. In conclusion, Kubernetes has become the de facto standard for container orchestration due to its robust features, scalability, and active community support. The platform simplifies the management of containerized applications, enabling organizations to deploy, scale, and operate their applications with ease. While the complexity of Kubernetes can be a barrier to adoption, managed services and ongoing developments are making it more accessible to a broader audience. As the cloud-native ecosystem continues to evolve, Kubernetes will remain a critical component in the deployment and management of modern applications. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.